So we have this problem, and we're going to ask it a little bit differently now. And we have this new leash on the dog, and we're asked, okay, so we're going around in a circle, but the only thing that we know is that he ran a full circle, and we know that the total distance they ran is 12 pi. So this is technically the arc length that the dog ran. So this is really the total distance. So this is 12 pi. And if they ran a full circle, so what would this be in radians? Well, a full circle is 360, but in radians it's 2 pi. So what this would look like is r times 2 pi. So what we need to figure out is what exactly r is in order for this to be 12 pi. So we divide this by 2 pi, and we get that the radius has to be 6 in order for this to have 12 pi for a total distance that the dog ran. If the dog ran 2 full circles, that would be 720 degrees, which would translate to, if you converted that to radians, to 4 pi. Now the only difference for this problem is that instead of 2 pi, it would be 12 pi equals r times 4 pi. So we divide by 4 pi, and the radius of this circle is going to be 3 feet. So this formula, the arc length is equal to the radius times your angle in radians, is going to be helpful. And you might look at this and you might say, this next question has nothing to do with what this next problem is asking, but I'll explain to you how it's actually structured. So it says, suppose Lake Crystal is exactly due north of Kansas City. Suppose, given that Lake Crystal is at approximately 45 degrees north. Now, the way that this would look is, if we have the equator, we would have Kansas City here at 39 degrees, and we would have Lake Crystal at 45 degrees. Okay, so the question is, given that they are at this degrees north, how far are they away from each other? Well, if we talk about a central angle from the center of the Earth, then we can talk about this as a 6-degree angle. Well, if we convert this to radians, it's 6 pi over 180. Which is pi over 30. Okay, so this is my angle. If the radius of the Earth is approximately 6,400 kilometers, then what we need to do is we need to figure out just exactly what this distance is right here, from this point here to that point. Well, there's a 6-degree difference, so that's a 6-degree arc length that we have to find. So S is going to be R, which is 6,400, times our angle in radians, or pi over 30. So if I multiply that, I get what S is equal to. And if you multiply that out, you'll get an approximate answer in kilometers. Now, the unit conversion we can talk about in class, but this is what we were given for the problem, and if you want a unit conversion for kilometers to miles, I can give that to you in class. But your answer you should get is somewhere around, if I did the calculation right, it should be around 670. Yeah, you should have something about 670 kilometers. Now, if we are to find circumference, we can also talk about area too. And what I want to define is this idea of what's called a sector. Now, if we have this central angle, imagine, if you will, a circular piece of pie, or a pie, and you have a piece of pie. A sector is just a region of a circle cut by a central angle. Okay, so we have this central angle. Now, again, this central angle is proportional to the entire circle. So if we find the area of the circle, it's pi r squared. But again, if we want a proportional fraction of the circle, we would times it by the fractional proportion of the circle that we're taking of the area. So what we actually have to do now is we have to times it by how we would convert this to our angle. So how would this look? Well, if we have an angle, we have to describe it in radians. So how would this look? Well, if we're given a radius and an angle, the area would be pi r squared times the fraction of our circle. Well, the angle that we're given times the whole circle in radians, well, the whole circle would be 2 pi. Now notice we have a pi, another pi that can cancel out. Because again, this here is the fraction of the circle, or the central angle. So the way that this simplifies is 1/2 r squared times our angle in radians. So let's take a look at how this applies. Suppose a farmer has a circular pasture with a radius of 300 yards and wants to cut off a 60-degree sector. So you should know by now that that reduces to pi over 3 just for his cattle. What area will the cattle have just for themselves? Well, based on this area formula, it's 1/2 times your radius, so times 300 squared, times pi over 3. So if I times all of this together, I take 1/2 times pi over 3, so that's pi over 6, times 300 times 300, I get 90,000, which is going to reduce to 90,000 pi over 6. So if I multiply that all out to get an answer, I get about 47,000 feet. Or excuse me, yards. And that's going to be square yards. So this area here is 47,100 square yards. Now, for these examples, it's a simple matter of looking at this and finding out what's needed or what's missing. So if your area is 11 pi and your radius is 3, you have to just solve for theta. So you take this and say, well, 11 pi equals 9 over 2 times theta. Solve this for theta and figure out what theta is. The same thing is true for any one of these. Figure out what the missing variable is. Okay? So you're solving for the missing piece that you don't know. And the same thing is true for any one of these. So the goal for this section is to understand area and arc length and how they are related to the radians formula that we've talked about in section 3, or section 1 from chapter 3.